IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, Brad Jolley, healthcare technical specialist at Keysight Technologies, takes the time to delve into the topic of battery optimization with me, looking more specifically at battery life, runtime, and performance. Welcome back, everyone, to Season 3 of IoT Unplugged. In this episode, I'm joined by Brad Jolley, Healthcare Technical Specialist at Keysight Technologies. Brad, thank you for being here today.
Thank you, Caitlin. It's great to be here.
Could you start us off by just talking a little bit about who you are and what you do at Keysight?
Sure. So thank you, first of all, for having me on the podcast. It's really an honor for me to be with you. And as you mentioned, my name is Brad Jolley, and I'm been blessed to have a very long and varied career at Keysight, going all the way back to 1996, when we were still the electronic test and measurement portion of Hewlett-Packard. In November of 1999, we spun off from HP and became Agilent. And then in 2014, we spun off from Agilent and became Keysight. So we've been Keysight for about a decade now. And my career has included a lot of interesting roles in technical writing, R&D, software, application engineering, training management, technical marketing, and a lot more. But my current role is I'm a healthcare technical specialist, which is a great way to combine a lot of the things I've learned over the past 3 decades to help our healthcare and medical device customers address their technical issues and challenges.
Great, pretty concise introduction. Thank you for that, Brad. A main topic of our conversation here today is going to be looking at batteries in the IoT industry, which is a continually growing market. But before we get into the nitty-gritty of that, could you outline what applications and use cases in this industry use batteries?
Well, it'd be a lot simpler to list the IoT applications that don't require batteries, because that's going to be a lot shorter list. And so if you think about the things that make up the Internet of Things, they tend to be small, inexpensive sensors that don't do a lot individually, but they're located in places where you can't get AC power, and they provide a rich mosaic of technical information that really feeds into very powerful and interesting applications. It seems like these days people add the word smart in front of a lot of traditional verticals, right, and come up with IoT application spaces. You'll see vendors with solutions for smart utilities, smart environmental monitoring, smart homes, smart buildings, smart parking lots, even smart cows. That was an interesting application I saw where they're looking at temperature and pH inside the stomach of a cow. That's part of smart agriculture. And then we've got smart cities, smart waste management, and so on. And I've even seen smart clotheslines and clothespins that measure the humidity in the laundry that they're hanging. And so 2 areas that don't start with the word smart, but are certainly adding a lot of value, are the industrial Internet of Things, which is closely related to Industry 4.0, and the Internet of Medical Things, which includes things like wearables and implantable devices. And a lot of the customers that I talk with these days are doing connected medical devices in the Internet of Medical Things. And so to get back to the point of your question, Caitlin, pretty much all of these applications use battery-powered devices, and the battery is often critically important. For example, consider, if you would, asset tracking. At huge construction sites, factories, hospitals, it's critical to know what large equipment is available, where it's located, and what its usage profile is. And so in addition to the obvious security benefits, there are asset utilization and fleet management benefits. A bulldozer or portable imaging system that sits in the same location for 3 days probably isn't adding much value. But it's also important to know that just because a sensor is small and not connected to AC power, that doesn't mean it's battery powered necessarily. Because in addition to devices being powered by supercapacitors, there's a trend toward energy harvesting, in which small amounts of energy are obtained from sources in the vicinity of the device itself. And so these sources could include things like shocks and vibration, thermal gradients, fluid flows, and even electricity obtained from piezoelectric switches, or the triboelectric effect, which is simply a fancy name, a fancy way of saying that when you rub certain things together, you get a charge, and that's how you get static electricity.
So, with everything you've just said, all the different applications that use batteries in the IoT space, would you say there's one that you see more than most fueling the growth in this market?
I would say sensors, any sort of sensor, whatever it is, the sensors are the things that tend to uh, drive the growth in the IoT. The central devices are often AC powered, although some of them are not. The actuators sometimes will tend to need um more power than a battery can provide. But the sensors, I would say, would be the number one thing that's driving growth of batteries in the IoT.
Okay, and what I thought was interesting as well was hearing you talk about, you've got smart agriculture now, where even cow stomach acid was being looked at, I believe, as the example you gave, and the term smart was used a lot. With all that said, do you think that battery life is being thought about enough when it comes to the design and development of these kinds of technologies, or do you think an excitement that overtakes companies and they end up releasing solutions or products before properly considering how battery life might affect their performance? What are your thoughts on that?
Well, so I think designers are generally doing a good job, but you correctly point out, Caitlin, that there's always a tension between time spent designing and testing devices and time to market. Right? That's been true since products started being developed. And so the good news is that there are a lot of tools that have been developed recently that will really help developers optimize the battery life, because you don't want to release a product that doesn't have the good battery life. And so, for example, a lot of the improvements that support improved battery life are now available in very low power chipsets that run at sub 1 volt power rails, and they consume very low power. And so, some of the protocols, such as Bluetooth Low Energy, are also very helpful for developers. Bluetooth Low Energy uses a lot less power than Bluetooth Classic used to use, and still does use. Another example is electronic design automation software, which now does a pretty good job of analyzing power integrity and predicting current flow and voltage fading across the device early on in the device process, when it's still easy to make changes to the design. And then there's a bunch of innovative and interesting test technologies that are available. And so one example would be event-based power analysis, which allows engineers to correlate charge consumption with different device behaviors, including such things as RF communications and various electronic events going on inside the device. So, for example, you could measure current consumption over some period of time and then see how it correlates with Bluetooth advertising, flashing LEDs, data encryption, taking measurements, and things like that. Another example is a relatively new category of measurement device called a device current waveform analyzer that can measure extremely low currents with high bandwidth. And then finally, there's battery drain analysis tools and battery emulation systems that can really speed up the development of battery powered devices. In many cases, the emulator is actually preferable to using real batteries, and we can talk about that if you're interested, because of its excellent reproducibility and its ability to simulate a specific state of charge accurately and quickly, which really allows the engineer to get through a variety of tests very quickly. But in addition to using the technological tools, which I think are important, I think a lot of engineers are realizing that we can decrease time to market simply by learning from one another, right? There's a ton of published documentation on IoT device development out there, but sometimes the tendency for technologists is to think, oh, I need to personally develop everything and solve everything on my own, right? Because that's what I'm good at, and I like doing that. But in a lot of cases, it's better off just to leverage something that somebody else has already done and published, right? And I'm not talking about stealing intellectual property, but there's a lot of good information out there that's public domain that we can use. And so, for example, I was recently talking with a customer about some homemade software they had developed, and it was nice and it seemed to work okay. But it could have been solved by simply purchasing existing software that addressed that exact same problem. And the purchasing price would have been much, much, much cheaper than the time they spent on developing it. And it would have saved them really quite a bit of development time and troubleshooting time.
So you just spoke about all the different tools developers can use to optimize battery life. And what I thought was interesting, stressing this point about making use of the resources that are out there. I guess I'm just curious to understand from you and your experience, where does this resistance, or maybe resistance isn't the right word, but where does this unwillingness to make use of these resources come from?
So, to answer your question, Caitlin, I think that a lot of it, you're right, is not resistance. That's probably not the right word. I think that it's part of a mindset. And I'd be lying if I said that I didn't fall victim to this mindset. And that is, hey, there's a problem out there. I recognize the problem. Therefore, it's my job to come up with a solution to solve this, right? I'm hired by the company to solve problems. Therefore, I need to do this. A lot of times, the people then go to the next step of how do I solve the problem rather than how has the problem already been solved? Is there already advice that I can go that'll get me 90% of the way to a solution? Or do I really need to think through things from first principles? And when you think about the way engineers are educated, right, they're given a lot of problems that they have to solve on various tests, going all the way back through their math classes, their physics classes, their chemistry classes, their engineering classes, and so forth. And simply Googling an answer and cutting and pasting it isn't a great way to learn engineering, right? And so everybody agrees with that. But then once you're out in industry, uh, people think, oh, I have to do all the intellectual heavy lifting myself. And people forget that the answer might already be out there in a way that is perfectly ethical to obtain and use. And so, for example, if you look at the IEEE website, there's a lot of great information there, and it's all published, it's all public domain, and and I find that if I go there, I can often find great advice that I didn't have to do the original research on, and I can just leverage that. Another example would be the Association for the Advancement of Medical Instrumentation, or AMI, right? It's an industry group devoted to medical instruments and medical devices and medical systems. And it's a bunch of really smart people sharing information publicly with one another. And you can buy their technical information reports for a couple $100 and obtain all kinds of very useful information and advice, right? Without having to go through the process of figuring everything out on your own. But a lot of time, engineers have a certain preference almost for figuring out things themselves, right? It's there's a certain visceral satisfaction that one gets from solving problems that you don't get by simply looking it up, right? And so I think that those are the kinds of things that lead to engineers not taking advantage of information that would be perfectly useful and ethical to use.
Yeah, I think that's a really good way of putting it. When you think of an engineer, it's someone who wants to solve problems, so it probably doesn't necessarily come naturally or occur an engineer to think about the resources that are out there. So it's great that you listed some of them. For anyone listening, please do check them out. They sound like really useful tools or sources of information. Uh, we've spoken about the tools, we've spoken about the use cases. I just wanted to go back to this to uh, pick your brains about the requirements for battery life and consumption depending on the use case. Could you provide a summary of that?
So you make a really good point here, Caitlin, because different industries and different use cases do have very different battery power requirements. And so some of the times those requirements are obvious, things like the form factor, right? What's the size and shape I have to fit into, the price, the capacity. But some things are much less obvious, like the number of recharge cycles you have to be able to support, the predictability of end of life behavior, and even things like the ability to monitor temperature and interrupt thermal runaway, or to use smart charging and discharging to deal with cell imbalances that invariably occur. So when you think of a battery, there's an important thing to realize, and that is a battery is generally a collection of cells. It's not just one cell, right? And if you don't have those cells balanced, you will get various chemical behaviors that will A, shorten the life of the battery, and B, can lead to safety events such as heating and thermal runaway. Another thing that may be more or less important for various applications is the failure mechanism for mechanical stresses and strains. And so, for example, suppose you unintentionally pull on a cable and the connector tab to the battery breaks. How exactly does that break occur? Do the welds that attach the tab to the battery break, which would violate the integrity of the battery case? Or do the welds hold firmly and force the tab itself to break? You would want the tab itself to break, right? Because that's going to be safer, because that's not going to affect the integrity of the case. And so, in the case of a device that gets installed in a fixed location, that's not an issue, right? You don't care. But think about a hospital environment where you've got a lot of connected medical devices that are often rolling around and moving with patients. The probability of a cable strain may increase. And so you need to think about failure mechanisms for batteries, right? Venting is another important feature in some batteries because you can get gases that build up pressure inside the battery, and so you have to be able to vent there. Another really important thing to consider is that the engineers who are writing that firmware that runs on an IoT device, the software people may be able to actually mitigate some of the problems with less than ideal battery life by the way they write the firmware. And so, for example, depending on the information that you get from the battery management system, your device firmware may be able to change the operational behavior of the device, or at least warn the user that a battery problem is going to occur soon.
Thank you for that, Brad. I think it was a pretty good overview. Following on from that, what would your recommendations be to manufacturers who want to optimize their battery life?
Well, Caitlin, you're wise to use the word optimize rather than maximize. And in fact, maximizing battery life is not always a good thing, okay, which seems counterintuitive given what we've been talking about, but let me explain. So, when you're engineering an IoT device or any other device for that matter, you're not trying to maximize battery life. You're trying to optimize some overall combination of functionality and performance, right, that serves the needs of the user. And so battery life is certainly part of that equation, but it's not always the case that maximized battery life optimizes the user satisfaction. And so let me give you a specific example in the IoT. A lot of IoT devices contain Bluetooth low energy radios, right, or something similar. And you can always save energy just simply by advertising at less frequent intervals or by transmitting at lower power levels. Will these, ideas lengthen battery life? Yes, they will. However, if you decrease the transmit power too much, then customers may not be able to communicate over the desired distances, right? And if you advertise infrequently, the customers may not find your device or may take several retries to do so. And so we need to distinguish also between what we mean by battery life versus battery runtime. Different people uses those terms differently, but the way I use the terms, battery life is the length of time before you have to install a new battery, and battery runtime is the length of time that a battery can properly power a device on a single charge. And so for non-rechargeable batteries, these are the same thing. Okay. But for rechargeable batteries, I would argue that battery life is much more important than the runtime. And especially with things like implanted medical devices, right? Where if you can safely and conveniently recharge a device wirelessly that's implanted in a human body, that battery life is going to be way more important than the runtime, especially if you have to do a surgery to change the battery. And so the key thing I would emphasize is you are absolutely right to point out that you want to optimize the battery life, which doesn't mean maximize the battery life.
I felt like there were a couple of important distinctions you made there. So, for one, going back to the maximizing versus optimizing, but also battery life and what was the battery runtime? Do you
Runtime. Right. Runtime is, how long is it going to power my device properly, right? Um, before I have to recharge. And yes, it's annoying to have to recharge, but for implanted devices, I'll recharge more frequently if it allows me to avoid a surgery.
Okay, so my next question really is, from your experience working with customers, is there perhaps a misconception between those two sets of terms, between maximizing and optimizing, and battery life and battery runtime?
Battery life and battery runtime, yes, I see that all over the place, and I want to emphasize that these are the ways I use the terms, but different people, very competent people, will use the terms differently, and so it's not a matter of right and wrong in this case. It's a matter of just making sure that you're all on the same page in the terminology that you use, right? And in terms of maximizing versus optimizing, I'm afraid that again engineers tend to have a mindset where they think, I need to make this as good as possible, right? I need to do something that's never been done before, make it really awesome and achieve the industry's best battery life or the industry's fastest data throughput or whatever, right? Because it's fun to put those things on a spec sheet and to it's kind of a point of pride to say I did this, and that's true, right? That's good, and it can often be a good thing. But the customer at the end of the day is really concerned with an overall set of experiences. And if the overall set of experiences and functions and capabilities provides that, and it would decrease the overall satisfaction to optimize one particular dimension, then perhaps it's not the right thing to optimize any particular dimension. And this applies to more than just batteries, right? This applies to things like size. You'll hear people say, "Oh, we've got the world's smallest whatever," right? Well, maybe the screen is so small that it's almost impossible to read unless you're, an 18-year-old with perfect vision, right? Well, congratulations on having the world's smallest whatever, but maybe a slightly larger screen would actually deliver more benefit to the user.
It sounds like there are a lot of moving parts in trying to find the best solution, depending on the use case, depending on the requirements, depending on the application.
It all goes back to that, right? What are we trying to achieve here? At the end of the day, there's some user or set of users that are trying to do something. How can I best help them use it? And I'm not opposed to long battery life. That's fine, right? I'm not opposed to long battery runtime. Those are all good things. But sometimes in the quest for one certain optimizing one particular parameter, you can lead to suboptimal performance that degrades the overall experience. Again, I go back to the example of RF power. You can always crank down the RF power on your device at which you transmit to use less battery power. That will, in fact, extend the battery life. But does that mean that you can't communicate more than 50 feet or more than 100 feet? What if the user needs 200 feet of communication, right? And so you always have to consider the full set of use cases before you decide what the optimal combination of various things is.
Great. Moving on to our next question. Looking at testing and software, how can it help to understand battery life? And what are sort of the parameters that, let's say, you at Keysight are looking for?
Well, testing and software, I think you've hit it. Those are extremely important. They're really critical to what we call energy budgets, which is where you figure out, okay, how am I going to spend the various amounts of battery charge that I have, right? And different test and measurement technologies look at different parameters. And so let's take a look at them. So one example is something called a device current waveform analyzer. And it looks at relatively mundane parameters like current and voltage, but it measures current at very, very low levels with great precision and high bandwidth. And that's super important with the new devices that are coming out because they're running at lower and lower and lower power. And they're running at faster and faster speeds. So the device current waveform analyzer is great for that. And you can also even log so much data that you can actually apply machine learning to it to find anomalies There were some Japanese university researchers at Waseda University that actually were able to find IoT security issues in the device just by looking at the way the current waveform moved, which was pretty interesting. Then there's another technology called event-based power analysis. And what that does is it uses source measure units to measure the current. And then its real claim to fame, though, is that it correlates those measurements with various device behaviors, such as RF communications and various components in the device turning on and off. And then it gives you a bunch of statistics and chart that help you understand exactly where you're spending your charge. Then finally, there's these battery emulators, and they create a model of a battery runtime profile by measuring an actual battery as it runs down as the device operates. And it measures the battery's series resistance, its open circuit voltage, and its state of charge. And then the engineer can use that profile to emulate, charge, and discharge and cycle batteries without needing more batteries, which actually turns out to be a tremendous savings in terms of time, because you don't have to figure out, okay, how do I get a real battery to 40% state of charge or 20% state of charge or 100%? You can actually just program that in with the emulator, and it saves a tremendous amount of time.
Would you always recommend performing testing?
Oh, yeah. I would always recommend performing at least some testing, but the testing methodologies and the scopes of responsibilities that I would recommend really vary depending on the nature of the application and the consequences of premature battery failure in those applications. And so, in most cases, the device manufacturer would be very wise to leave whole swaths of testing to the battery manufacturers. Things like manufacturing tests, cell matching tests, destructive tests, mechanical and chemical safety tests, BMS firmware quality tests, storage and shipping tests, environmental tests, and other regulatory tests. Those are simply beyond the purview and competence of your average device manufacturer. So, as tempting as it might be for an engineer to say, oh, I need to solve this problem, maybe it's just better to let your battery manufacturer do that and then audit them to verify that they're actually doing it. But on the other hand, it's probably unreasonable to expect anybody other than the IoT device manufacturer to do things like battery profiles, battery rundown tests, charging and discharging against those specific profiles, your event-based power analysis, your end-of-life behavior testing. These are all going to depend on the device, and doing those in-house really gives the device manufacturer the insights necessary to make firmware changes and to evaluate the quantitative effects of those changes on battery life.
Well, one message I can certainly take from our conversation today, Brad, is the topic or the focus on knowledge sharing. With that said, do you have any final thoughts for those who are listening today?
I do. The number one thing I would emphasize is to keep safety very high on the list of priorities, right? Um, it's great to be concerned with the safety of your customers and those who are affected by your device. But once a company gets to a certain level of size and influence, they really might want to consider auditing their whole manufacturing supply chain, including the manufacturing plants. You may have seen the news about that terrible battery manufacturing fire in South Korea recently that killed more than 20 people, right? The great thing about modern batteries is they have a tremendous amount of energy stored in very small spaces. The problem is they have a tremendous amount of energy stored in very small spaces. And it was absolutely tragic to see more than 20 people killed in this fire. And I was actually recently talking with some senior supply chain principal engineers of a medical systems company who had actually visited a manufacturing plant for a new battery vendor they were considering. And they were frankly appalled by the lack of fire suppression equipment. And they shared their concerns with the manufacturer and did not select them for that reason. So I would say that as great as batteries are, they can be very dangerous. So my first recommendation would be around safety. And the second thought would be then never stop learning. There's just so much to know, and nobody can even pretend to know everything about batteries, right? Every time I go to a battery conference, I end up with a ton of new knowledge, and an even larger list of things that I need to understand better, right? I go in thinking I know something, and I walk out realizing how much I still have to learn. Finally, I would ask people to contribute to the development and promotion of industry standards that'll make things better for all of us. And sometimes those of us working around the IoT get so excited and so intrigued by the technological possibilities that we forget that the whole point of engineering should be to solve problems that contribute to genuine human flourishing.
It's a great note to end on. I appreciate you taking the time to talk with me today, Brad. So thanks very much.
Well, it was a delight to be here with you, Caitlin. I really enjoyed it.
IoT Unplugged.